Hey Precalc friends, this is section 6.4 notes. Today we are going to be talking about law of sines. The law of sines is used to solve primarily oblique triangles, and oblique means that there are no right angles, okay? It can also be used to solve right triangles, but we normally wouldn't use the law of sines if we can use SOHCAHTOA. Okay, this should be a review from geometry. We do learn the law of sines in geometry, but you're probably a little rusty, okay? So when we think about trying to prove that two triangles are congruent to each other from geometry, if you remember, we learned a couple of methods. We have angle, side angle, side angle, side, angle, angle, side, 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 and hypotenuse leg. Okay, these were all methods for proving that triangles are congruent. Non-methods for proving triangle congruency would be side, side angle, or angle, angle, angle. Okay, so the law of sines is used to solve a triangle when the given information satisfies either angle, side angle, side angle, angle, or side, side angle. Now we have to be careful with that one. That one is called the ambiguous case. And we will get to that a little bit later, okay? But that's something that we always have to check for when we're using the law of sines, because most of the time we are looking at the side, side angle. Notice I did not say angle, side, side, because that would be abbreviated ASS, and we certainly don't want to have ASS written all over our paper, so we are going to call that the side, side angle case or the ambiguous case. So the law of sines, if we look at this picture, please notice that for the given triangle, the angles are denoted with capital A, B, and C, and the side lengths are denoted with lowercase a, b, and c. Side A being directly across from angle A, side B being directly across from angle B, and side C being directly across from angle C. So notation is really important with the law of sines. Here it is. The sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. And again, you can use any two of these three and set them equal to each other. So if you know sine, if you know angle A, side A, and side B, you can then solve for angle B. You don't have to know anything about C to be able to use the law of sines, or vice versa. Let's take a look at our first example. Okay, we've got a triangle and we've got some given information. So the first thing we're going to do is we're going to fill the given information in the picture. The measure of angle A is 22 degrees. The measure of angle B is 95 degrees. And side A, which we know would be directly across from angle A, is going to be 420. By the information that we are given, this triangle satisfies side, angle, angle, right? Okay, so the first thing that I am going to do is I am going to use the fact that I know both angle A and side A. And since I know angle B, the first thing that I could do is I could solve for side B. Then I could solve for side C. And angle C is easy to figure out because to find angle C, I can just subtract. So actually, let's start by solving for angle C. Okay, angle C is just going to be equal to 180 degrees minus 22 degrees minus 95 degrees, which tells us that angle C has to be 63 degrees. Okay, so now that I've got that, I'm going to use the law of sines, and I'm going to say that the sine of angle A over side A is equal to the sine of angle B over side B. So my first equation, when I start plugging in numbers, is going to be sine of 22 degrees divided by 420 is equal to sine of 95 degrees divided by B, right? Because we're trying to find side B. Okay, so we do some fancy algebra here. We're going to multiply both sides by B to get B out of the denominator. And we're also going to multiply both sides by 420 to get 420 out of the denominator. So our first step is going to turn this equation into B times sine of 22 degrees equals 420 times sine of 95 degrees. And then to get B alone, we're going to divide by sine of 22. So B is going to be equal to 420 times the sine of 95 degrees divided by the sine of 22 degrees. You grab your calculator, you make sure that you are in degree mode first, okay? 420 times the sine of 95, hit enter, then divided by sine of 22, hit enter. We should get that the length of side B is 1,116.9. Since we don't know what we're measuring in, we're just going to call it units. Should always make sure we put a label though, okay? And now we can find side C using the law of sines again. So this time I'm going to use sine A over A equals sine C over C. So my equation is going to become sine of 22 degrees over 420 is equal to sine of 63 degrees divided by side C. And again, I'm going to do that same algebra that I did. I'm going to multiply both sides by C to get that out of the denominator. So on the left-hand side, I'm going to have C times the sine of 22 degrees. And then I'm going to multiply both sides by 420 to get that on the out of the denominator. So then on the right-hand side, I will have 420 times the sine of 63 degrees. Then I'm going to I'm going to divide both sides by sine 22. So C is going to be equal to 420 times the sine of 60 degrees divided by the sine of 22 degrees. I grab my calculator, again, degree mode, make sure, and we end up with 999 units. Okay, so I have solved my triangle. Side B is 1116.9, and side C is 999. I now have all three angles and all three sides. I have solved the triangle completely. All right, now it's time to talk about the ambiguous case. The last example, our triangle was a side angle angle, so we didn't have to worry about the ambiguous case, okay? When you have a triangle that satisfies side-side angle, you can either make no triangle, as is in the picture below, or one triangle, which is what we hope for because that's easier, or two possible triangles. Okay, and this will come out as you are solving the problem. You don't know what you're going to have until you do the math to figure it out. Okay, so with our given information, we could have any of these three options, and we just have to dig into the problem and do the math and figure it out. So for the next example, we have a triangle. As you can see, we have given information for us. We have two sides and we have one angle. So this given information satisfies the side-side angle scenario. All right, so the first thing that I'm going to do, I'm going to use the fact that I know both angle A and side A, and the fact that I know side B. So the first thing that I'm going to do is I am going to solve for angle B using the law of sines. Sine of A over A is equal to sine of B over B. When I plug the numbers that I know into this equation, I'm going to have sine of 135 over 100 equals sine B over side B, which is 80. Okay. I do my algebra here. So what I'm going to end up with is the sine of angle B is going to be equal to 80 times the sine of 135 over 100. Okay, now I can do the math there. 80 times sine of 135 divided by 100 tells me that the sine of angle B is 0.5657. But now to find angle B, okay, I have to do inverse sine on my calculator. So angle B is going to be equal to the inverse sine of 0.5657, which gives me 34.4 degrees. Again, check this on your calculator and make sure you know how to do the computations. So I've got my angle B, it's 34.4 degrees. And now that I know angle B, I was given angle A, I'm able to subtract from 180 to find angle C. So now I can say angle C is going to be equal to 180 degrees minus 135 degrees minus 34.4 degrees. So I find out that angle C is going to be equal to 10.6 degrees. So I have one more piece of information that I need to find, and that is going to be side C. I found angle C, I found angle B. So I'm going to again use the law of sines to solve for side C. And I always like to go back to using the information that I'm given in the problem just because I feel like that's safest. So I am going to go with sine of A over A is equal to sine of C over C. And when I plug numbers into that, I'm going to have the sine of 135 degrees over 100 is equal to the sine of 10.6 over C. Do some math here. Get that C out of the denominator by multiplying both sides by C, and then multiply by the reciprocal of sine of 135 over 100. So I end up with C is equal to 100 times the sine of 10.6 divided by the sine of 135. Grab my calculator, make sure I'm in degree mode, and I end up with C equals 26. Okay, so I have solved the triangle. However, now I need to stop because this triangle was a side-side angle triangle. It is possible that there could be a second triangle. I know for sure there's one because I just found it, but I have to figure out if there's a possible second triangle. And the way that I do that is I go back to the first angle that I found. Okay, so in the case of this problem, the first angle that I found was angle B right here. Okay, so I know that angle B was 34.4 degrees. Okay, that's going to help me decide if there is a second triangle. Okay, we found that the sine of angle B was 0.5657. We know that sine is positive in quadrants 1 and 2. So angle B could either be an angle in quadrant 1. So in that case, it would be the angle that we already found, which is 34.4 degrees. Okay, or it could be an angle in quadrant 2. If it's an angle in quadrant 2, then angle B could be 180 degrees minus 34.4 degrees, which would be 145.6 degrees. So that's the other possible angle B. So then the question is, can angle B equal 145.6 degrees? Well, let's find out. Angle A was given. So angle A was 135 degrees. That was given. Given information can't change.